Here are 10 limitations of large language models and some options to provide mitigation. First, we're going to introduce the concept of hallucinations. Then we're going to cover performance and inference costs, stale training data, how to use models with private data, token limits and context window size, the fact that LLMs by definition only support plain text and converting documents to plain text is often an imperfect process, lack of transparency and explainability, ethical concerns, training and fine-tuning, costs, and more. A couple of things about myself. I'm responsible for large-scale cloud-native and AI solutions at IBM, and I'm also leading development of a inner-source retrieval-augmented-generation platform that uses vector databases, Watson-X LangChain, and open source and IBM proprietary models. All right, let's take a look at hallucinations. Because models are designed to produce coherent and fluent text, they can often hallucinate and generate text that is incorrect, but often seems plausible. The lack of context or contextual understanding of the input prompt are key reasons why LLMs hallucinate. So, what does this mean in practice? Well, the input prompt is contradictory or often unclear, or doesn't provide sufficient examples of the desired output, or it lacks the context to respond. So if you have unclear input, most likely you're going to get a hallucination as an output. It could also be that the data quality or training method was based on old, noisy, low quality data. And, here's an example. It was trained on Reddit data or Twitter data or forum data or very large amounts of low quality data sets. So if you train it on Wikipedia, you're going to get decent results, but you still need a lot of content. So you're going to supplement your training data set with various forums, Twitter data, open data, and then the quality of the output is going to lack. It could also be an issue of the generation method. So models and their weights might be biased towards specific languages, specific words, or specific data. Here's some workarounds. Advanced prompt engineering can help. It can help a lot. So, for example, if your prompt has something like if a question does not make sense or is not factually coherent, explain why instead of answering the question, it can help overcome some of the hallucinations. It can also provide examples using one-shot prompted or few-shot prompting, where you give examples to the LLM of what the output should be, and this can help quite a bit. Advanced forms of prompt engineering include retrieval-augmented-generation, where you're really injecting data, either from an API, a data set, the internet, or a vector database, into the prompt. Now, you are limited by the token limit, but this can really help because it provides context and grounding. Other workarounds include using a more performant model, testing the quality of responses, or reinforcement learning from human feedback. Just for context, here's how Llama 2 is prompted. So when you use Llama 2 chat, you're going to see that the prompt behind the scenes is something like this. So every time you talk to it, it adds this as context. So you're a helpful, respectful, honest assistant. And if a question doesn't make sense, don't respond, say you don't know the answer, and so on. So prompting does actually help reduce the occurrence of hallucinations, but of course, it cannot eliminate it completely. Same for retrieval-augmented generation by using a vector database. You're able to inject relevant context into those prompts within your token limit, and then the model will perform better. But you're also able to point at content saying, here's where the information was generated from. Here's the context it was generated from. Performance. This is a big issue for a lot of these LLMs. You're really introducing something that performs as well as a fast typist into your architecture, or as a very slow dial-up modem. In fact, even some of the earlier dial-up modems of the 1990s were 10 times faster than what you can get with an LLM. They also suffer from latency or time to first token. So every time you have a conversation or you're doing something with an LLM, expect 10, 20, 30-second response time on average. Even with streaming, that's a lot of time to wait. It also means that many of the workarounds include throwing hardware and money at the problem, or using smaller models or generating fewer tokens. Some of the architectures kind of prevent you from using an LLM for, say, credit card transaction processing, looking for fraud detection, for example. Yeah, that's really not going to happen today with an LLM, simply because of the volume of transactions. It will be extremely expensive and very, very slow to perform this kind of thing. Or using an LLM to verify every single line in a log file for identifying issues with an application. Yeah, you can do it in theory, but it's going to be extremely expensive and quite unreliable given some of the hallucinations we've talked about previously as well. Inference costs, these are derived from the performance as well, make models expensive to run. More often than not, running a large model, the 180B Falcon, for example, needs about 5 A100 GPUs to run. Or even a quantized version of Llama could take up a whole GPU, right? One query at a time, one person at a time. So you're likely to pay to run these LLMs about as much as you would pay for somebody to actually type that stuff by hand. These are expensive, and queries add up, costs add up, especially if you're not asking the right question. So a brute force approach really doesn't work, right? A dedicated AI100 can cost you $20K a month with a cloud provider. Using a shared platform does help. Using a quantized model does trade off quality for performance. So this isn't a workaround, right? You can take a 16-bit model, lower the precision to 8-bit, 6-bit, 4-bit, and even 3-bit, and run it on a cheaper GPU, or run multiple instances of the model on the same GPU, or it'll perform faster. But again, this is the same as running a smaller model. You are trading off the quality of the response for cost and performance. Another issue is stale training data. These models, cost 20, 40 million to train. You're not going to train them every day, and training them also means that you're, literally downloading the whole internet. So they'll have a cutoff date, right? November 2021 cutoff date for, one of the large commercial models. So these models don't have access to the internet. They haven't been trained necessarily on recent data. It doesn't even mean recent data might be prioritized in the model response. So a couple of workarounds here is, find a more recent model, retrain the model, fine tuning, or again, retrieval-augmented generation, or some form of, plugin that gives the model an internet search capability, which is really just a form of RAG, right? These models don't have internet access. They're a function. Takes text as input, generates text as output, does it once, doesn't learn from the experience, doesn't do anything from the experience, right? So for it to, quote, use the internet, you are writing code that does a, Google search, Bing search, whatever else, selects the top 10 results, feeds that text as input prompt, as context, assuming it is within the context window, and gives you back an answer. The use of models with private data is also an issue, as they really, really haven't been trained on your data. And right now, training is still prohibitive for a lot of use cases. You can't just throw 1 million, 10 million, 100 million, depending on the size of the model, to go off and build your own GPU cluster or start training models just for your dataset. It also doesn't work if your dataset comes in, real time, right? You can train it on log, but new data might come in, right? So what do? Well, again, we're back to using retrieval-augmented generation or injecting context. All right, let's talk about token limits and context window size. Here we go again with a limitation where you can only feed them all a couple of pages of text. 4,096 tokens. A token is 3/4 of a word. 3,000 words for some of the best open source models, including even ChatGPT has 4K. Then there's an 8K version, 16K version. There's a 100K model out there as well. But all of these models tend to perform poorly after 4K as well. So you're still gonna have this issue. You can't just feed an LLM your entire set of documents or even a whole document and say, hey, go summarize this book for me. It doesn't work that way, right? It's a process where you'll need to chunk it, split it, and perform multiple queries and chain things, and it becomes quite complex. LLMs only support plain text. Now, this should be obvious from the name. I'm not saying you don't have image generation or image recognition or whatever models, but really, if you're using an LLM, Llama 2, ChatGPT, whatever else it is, it only processes plain text. You can't just go off and give it a PDF file or a Word document and say, move things around in heading 1 and heading 2 and heading 3 and so on and so forth. If you're able to do that, that means somebody behind the scenes has written an API or a tool that, does PDF to text, takes the text, and it cleans up the text, it converts it, it feeds it to the model as plain text. If you see a model generate HTML or a Word document or anything behind the scenes, again, it's generating plain text, and then you're converting it with some level of formatting. I know you can use trickery, like generate Markdown or HTML, and then you convert those to more binary formats or docx. But a lot of the heavy lifting is done by you in the conversion process. So having a good data pipeline is important, but also understanding the limitations, right? It's a PDF document. Does it have images? Do you use OCR? Do you use a multimodal approach? What about tables? How do you convert those? What if the document isn't structured in a way which is easy for the model to understand? So this limitation can lead to poor prompting in patterns such as RAG. So conversion can be quite a key issue. Lack of transparency and explainability is also a concern. You get an answer. Maybe it's not a hallucination. Great. But was it based on recent data? I don't know, right? A model won't tell you, by the way, the answer I've generated is based on this data I was trained with. So you can use content grounding or RAG as a mitigation where you feed it content as part of a RAG pattern. And then you can say, by the way, this is the prompt and the context I fed this model in order to generate this answer. So there is a mitigation, is again not complete because you can't really say what data went into generating what answer. And it's really not necessarily even a reproducible process. Same for ethical concerns. Answers can be outright harmful or completely incorrect or fake, or there's quite a lot of issues, or biased, or they can even have ethical concerns. You can really get in trouble with this, right? Even copyright issues could be a problem here. There are mitigations, so you can use open source models where you know the data lineage. You read the white paper, you can see the training data, you can look at it and say, this is what it was trained on. You can implement harm filters, which is anywhere from a regular expression for naughty words in the output to a very complex model that investigates the output of the previous model. So, this can be quite complex. You can have a governance framework where you record the input, the output, and you see how it drifts over time. There's frameworks for specific outputs, blue, rouge, whatever, type of metrics for looking at summarization quality and so on. But again, mitigations require complex architectures and development to get there. You can also do reinforcement learning from human feedback. So hopefully your performance and response and so on is going to improve over time thanks to human feedback. One example would be, you're doing summarization with an LM, you're recording what summarization should have been from a human actor, and then you're using that data to do fine tuning of the model. Last but not least, these models are expensive to train and to fine tune. So if you look at the Llama 2 paper, they spent, millions of hours of GPU time with, A100 GPUs, 400 watts each, to train them all. So to put that in perspective, that's 20 to 40 million in training costs with electricity, not to mention what it would take to download and store the data. So workaround is don't go off and train your own model. You're not gonna download the whole internet, do it better than one of the major players, and then train it on clusters of thousands of GPUs. By the time you have your model trained, a better model will probably be out there. So try to use an open source or an existing model, fine-tune it if you wish, but share your learnings, your training data. Avoid building something proprietary at one time, because these models tend to evolve over time, and it doesn't help if everybody goes off and spends millions of dollars and tons of carbon emissions just to train a model that's going to be obsolete by the time it finishes the training. If you want to learn more, you can follow my YouTube channel, and you can find this talk available on GitHub. Thank you.